All right, folks, welcome to the webinar, and we'll get started in about 1 minute. All right, folks. Well, thank you for joining us today. I'm Kelly Hill, and I'll be your moderator today. This is brought to you from RCR Wireless News. So I'm Kelly Hill, editor for Test and Measurement with RCR. Joining us today, we also have Derek Curtin, who is principal analyst with Curtin Group and chairman of the IoT Forum. We're also joined by Mike Eftimakis, who is IoT product manager for ARM, and Ken Hosak, VP of IoT strategy and business development for Cradlepoint. So a lot of good and varied perspectives today as we get ready for this discussion. Just touching on a few recent pieces of notable IoT news. So we had Verizon and T-Mobile US both recently announcing successful tests of narrowband IoT and guard bands in preparation for network launches over the course of this year. Rotterdam announced a goal to become the most IoT connected port in the world that involved partnering with IBM and Cisco, among some other companies, for that project. And meanwhile, the Science Foundation in Ireland launched a new $18 million research program centered around smart city IoT. So a lot of new money going into research that's IoT related in Europe. On the security side, I thought this was a really interesting thing that emerged just in the past week or so. There was a new IoT device-fueled botnet, pretty small in range. It was actually targeting, I think, one of the Grand Theft Auto servers, identified by a Radware security researcher. And it was using hosted servers to scan for, find, and infect new devices rather than spreading from IoT device to IoT device. So that was something new that popped up this week that came up in some of the security conversations around this report. So speaking of our Enterprise IoT Devices Special Report, available for download at rcrwirelessnews.com. Just a few key takeaways from the report. We're supposed to see more momentum in this area this year. And we're also going to see widespread deployment of NB-IoT networks. You know, obviously in the US, we just mentioned Verizon and T-Mobile. China is a particularly big market for NB-IoT, and so that's going to drive a lot of things this year. Enterprise IoT, when you get to security, that is still one of the top concerns and the barriers to adoption. We will definitely discuss that today. Enterprises have a number of options for IoT design. When you want to put together a project, there's a lot of different ways to do it, all the way from sort of some of the more turnkey offerings to do it yourself. And the testing and design challenges change accordingly. Enterprise devices often require more testing than consumer devices in order to assure quality and reliability. One of the new things that came up that I thought was interesting for IoT test included considering deployments as a system rather than individual devices. You know, what is the difference in behavior and security thoughts and assurance when you're talking about 10,000 devices, versus 100, and what that means in terms of network behavior and monitoring. So those are some of the key takeaways. Now I'm going to pass things over to Derek, and take it away, Derek.
Great, Kelly. Thank you very much, and thanks to everyone for joining us. My name is Derek Curtin. As you can see, I'm chairman of the IoT Forum in Silicon Valley. And it's not up in print, but I'll mention I'm also chairman of something called the Telecom Council of Silicon Valley, which is an organization here that has about 100+ members. And I'm also actually run something called the Auto Tech Council in Silicon Valley. Each one of these things addresses a specific vertical and their needs in interfacing with Silicon Valley and capturing innovation. So just for example, in the Telecom Council, by 100 members, about 25 or so are some of the biggest phone companies in the world, and they're have field offices here in California, and the idea is to partner with startups to see the trends and to make sure that if there's an interesting innovation coming out of the Valley, that they're at the very least aware of it, and if it's something they want to partner with, they partner with it. So the IoT Forum does that specifically in the IoT space. If we go to the next slide, please. So just a little bit more about us and how we, the role of IoT Forum is to connect buyers and sellers of innovation, as I mentioned. So we do it by having regular meetings with our members, and we try to have about half people in attendance would be members who are there frequently, kind of know each other. It's kind of clubby, but half the people in attendance are new blood. So every time we talk about an idea, say 1 month, we'll have a meeting about agricultural vertical. We'll have specific farming cooperative delegates there. We'll have people from John Deere and such who specifically bring knowledge. And then we'll have startups who bring solutions to those markets. And then the next month, we'll switch to a different topic like HVAC or new real estate developments and such. Okay, next slide, please. So just to kick off and talk about the industrial IoT, I mean, I do a lot of work in both consumer and IoT. So I wanted to link the two and talk about the lessons we can take from one to the other. And I guess on the slide, you see the Rebel Wilson in the bathtub Amazon Alexa joke from the Super Bowl. But you also see a range of devices below, and I'll talk about those in a second. What we can learn, and then the industrial side from the consumers, is we can learn from the massive success of Amazon Alexa specifically. I'll talk about it, although you can see Google Home and HomeKit mentioned, but I'll just keep talking about Alexa since it's the leader. What Alexa has done is it's given people a base use case to use a smart home device. It's given them a reason to start. And from there, it has lowered the barriers to adopting other smart home services. So when people put one of these devices in their home, maybe they do it initially for the base use case. Well, it was only $40 for the dot. I wanted to get the weather. Or I wanted to get stock prices or news every in the morning when I wake up. So they buy it maybe for that base use case. But then they go, hey, I heard that this thing can control my lights. And I thought about buying one of those automatic lights 5 years ago, but I looked at I had to get the remote control, then I have to get a base module I plug into a plug, then I have to get the light bulbs themselves. It looked pretty complicated. But now I see Alexa does it, and they have recommended partners, and apparently it works really well with this Philips Hue bulb or something else. So it lowers the threshold for the consumer to go into this IoT space and to buy a connected light bulb or doorknob. And that's very important because one of the growths we're seeing, and the reason we're at a bit of an inflection point in the growth of consumer IoT is because, specifically Alexa has done that. It's offered a platform and offered a horizontalization, and therefore has made it really easy for, if you're the light bulb maker, it used to be you had to solve a big problem in terms of building your light bulb, building your controller, you had UI elements to consider, and then you had to educate the user, and you had to get out there in the market. A lot of those barriers are now removed. You still have to build a good product that works well, but if it works with Alexa, you can say, hey, listen, it works with Alexa, period. And people know Alexa. So the education element is gone, and the implementation for your customers is much easier. So that's why if you look at just about any product in the Best Buy or the Fry Electronics shelves these days, you'll see they all have works with Alexa if they're a consumer IoT product, because that tells consumers, hey, I've made this easier for you by working with Alexa. That's important. Do we have an Alexa in the industrial space is the big question. Frankly, we don't. But those are the kind of horizontalization and platform-based elements we're looking for. Okay, next slide, please. So enterprises are a little different than consumers. Consumers want something that's cool, that can give them a little bit of utility. Enterprises are much more sanguine. Listen, they're going to launch IoT if they can find a positive ROI in that investment. It's got to give them a certain rate of return on the investment they make, and they don't care if it looks good, they don't care if it's sexy, they just want to know if it can save them or make them money. But historically, if you look back to the 90s when John Deere started looking at agricultural IoT, they had to build all of the solutions themselves. They had to look from the ground up. Well, how do we get a sensor? How do we connect that to a power unit? How do we connect that to an antenna module and to an RF amplifier, et cetera? So they had to think through every one of these details. They got to think of John Deere as an agricultural company that's strong in certain agricultural manufacturing areas, but not so strong in the RF area or in the analytics area or in the RF power amplifier space. So to end up building that solution, soup to nuts, all themselves, was extremely difficult. What we have is some horizontal solutions appearing in the industrial IoT that are doing what Alexa has done in the consumer space. They're lowering the cost of IoT implementation for people like John Deere by saying, listen, we're going to give you a full module. You can plug in sensors. It's modular. And that'll take all that weight off of your back if you're John Deere, if you're Caterpillar, any of these verticalized companies can now say, hey, look, I can buy a module from a vendor, that does 10 of the 100 things I need to do. And buying those solutions in the modular capacity, you can not have to solve each problem yourself, which lowers the costs. My second bullet here, a sub-bullet, is very important because it's not just a matter of lowering the cost. Equally important, it de-risks the IoT implementation. What that means is that when you're somebody like John Deere, going back to them, and you're trying to put this RF together, this amplifier yourself, and it hasn't been tested yet, and Kelly's talked about testing and how important that becomes, you have hundreds of points of potential failure. Whereas if you buy a proven module that another vendor has sold in large scales already, all of a sudden, not only might the cost be lower, but the risk of something failing in that drops significantly. And when I talked about the top bullet about how companies seek positive ROI, well, if you know how to build a business case or business model going forward, you build it with the numbers you think might happen, and then you kind of multiply it by a risk factor. Like if you think that potential positive revenue has an 80% chance of actually materializing and a 20% chance of failing, you got to multiply the positive ROI by 0.8, which is actually pretty optimistic. If you can de-risk it, you can take it from a 0.8 to a 0.85 up to a 0.9. All of a sudden, the chance for positive ROI gets higher and higher. And then the other thing about horizontalization platforms is the way we see it right now is analytics platforms. We see it in modules that are being offered, and some of the other speakers on this panel will be talking about some of the modules. You see it in starter kits, and you see it in package solutions that are being offered. So those are horizontal solutions that are de-risking and lowering the costs. And basically, it gives the buy option in the classic build versus buy. Whereas when you jump back 5 years or more in the past, really you didn't have a whole lot of buy options in that build versus buy classic question. So my conclusion on this slide is that we should expect an explosion of industrial IoT to come out of this de-risking, and we're at that inflection point right now. If I go to the next slide, please. And just really quickly, 3 examples. What does horizontalization, as I call it, really look like? Well, I've looked at who my fellow panelists are and pulled a couple examples from them, their companies, and one other as well. So on the left, you'll see AT&T is offering a finished solution that logistics companies can put on containers, can put on tractor trailers, or can put on heavy equipment, like once again, a Caterpillar, a bulldozer, or something like that. And this sensor gives all-in-one GPS location, humidity, motion, temperature, shock, pressure, light, darkness, vibration. Now, what the cool thing is, maybe you don't care about half of those things. Maybe you really only care about GPS location and motion. Fine. Only pay attention to that sensor reading. But the thing is, by providing a modular solution or a finished platform-based solution, they've de-risked everything, and they give you something that is off the shelf, ready to go, and you can ignore some of the elements of it and still have lower cost, even though the module has functionality you don't even use. It's still cheaper to take that off-the-shelf solution, and the risk goes way down. Up in the top right, you see that ARM is powering this starter kit. Now, the interesting thing about this one is this an ARM product? No, it's actually an IBM product. So IBM has said, we want to be a big player in the Internet of Things. They've sought out to make a starter kit so that companies who wanted to get a little more soup to nuts than the AT&T example on the left, this is going to be a little more custom built using the starter kit. And they've said, we need a low-cost processor. So they've sourced that at ARM. So what you're seeing is that IBM has already put together a few different partners for their customer down the line. So they can go to the people making those solutions and say, listen, we've got a starter kit that can give you, get you 20% of the way there, but still offer you a lot of flexibility in building your IoT solution. And down below, you see a Cradlepoint device. And no, go understand, the interesting thing about this is it's not being sold by Cradlepoint, it's being sold by Verizon. So this is a solution that is not just giving you the hardware to be a base station to aggregate IoT nodes. It's also giving you the upstream backhaul connectivity through Verizon. So, should a buyer of this solution, do they have to worry about whether this will work with a mobile carrier? No. They will have one neck to strangle in that particular capacity. This is going to work with a mobile carrier because that's who they bought it from. So these are really interesting ways people have packaged things together to make it easier for the industrial IoT to jump forward. And that's horizontalization. And now, last slide, please, I'll very briefly talk about. This panel says we'll talk about security. I do want to mention that it's extremely important that this be thought of from day one, from the ground up. It's not a matter of building a castle and then saying, oh crap, we need security, and putting a moat around it. You kind of got to fortify the castle from the first brick onwards. Got to be thinking about protecting the castle. And that's the same thing here with IoT, whether it's consumer or enterprise IoT. And on ecosystems, my previous slide showed these great little modules and kits and starter kits and prepared solutions out of the box. That's great, but the truth is it's still pretty complex There is not a supply chain that is linear in the enterprise IoT. It's a web and a complex ecosystem, and people need to pick partners, and that slows you down a bit. I would say the one thing that enterprises can do in this complex ecosystem is kind of pick a starting point. It's like, where do I get started is one of the biggest questions I've heard from enterprises looking to adopt IoT. And my answer to them is, what's important to you? Is it that connectivity? Then you might look to a wireless network provider and make sure that the solution is endorsed by them. Is it ruggedness? Then you might look for a vendor who specializes in rugged modules and things like that. But pick an initial thing that really is important to you, a partner that you really like to work with because they seem like really good, or you already have a partnership with them in other ways. Start with one thing, lock that down, and then ask them, who should I look to upstream and downstream from you? So if it's Verizon in that one case back there, you might say, okay, Verizon, I'm working with you because you're already one of my preferred vendors. I want to build an IoT solution. Who do you recommend as the chipset? Who do you recommend as the module? Who do you recommend as the analytics platform on top of that? And what you get from that is you get to build a solution that you know will work together because it's upstream and downstream recommended by those partners, and they've done a little bit of work to make sure the solutions work together. So I believe that's the last slide that I was going to talk about. Thank you very much, and look forward to the Q&A portion.
Okay, great. Thanks, Derek. And now we're going to move on to Mike from ARM.
Hello, I'm Mike Eftimakis. I'm an IoT product manager at ARM, and I'm in charge of IoT systems. So as you probably know, ARM is focusing on building solutions for mostly chip manufacturers. But not only that, but we also have software, a lot of software activity. And I'm taking care of mostly the hardware, but also the software part for IoT. Next slide. So as I talked about ARM, I think the graph on the right-hand side shows you what actually we are doing. And you see that we have shipped more than 100 billion chips containing ARM technology up to now. And we expect in the 4 coming years to ship about the same. And most of this growth is due to IoT. So that's important for us. The other thing to note is that none of these chips have been manufactured by ARM. We are just providing the technology to chip manufacturers. And Derek just talked about ecosystems, etc. That's exactly what we are proposing, because we have partners who manufacture chips, manufacture silicon, that is then used in products, and they use our technology to put in their products. So that's how we reduce the cost of products. We design once, and it's used by many other manufacturers. And in IoT, that's also what we do. We design IoT solutions, we design software, and that goes into product. Next slide. So ARM is well known for the processors. We talk a lot about that. There are many IoT products in the world that already work using ARM processors. But we also have many other components that go into the creation of IoT chips. And of these components, we have, of course, security, which I will talk about a bit later. But we also have radios, libraries, all the elements that go into chips to form the foundation around the processor. And we, as I said, we have a lot of software activity where we work on all the elements that can enable an IoT solution. And these elements are the protocol stack for the communications, but also the power library, the security libraries. We have a large activity around the embedded OS, which is not an OS, but more than that, it's a framework to build IoT devices. And we also have some cloud services to connect to the devices and integrate with cloud applications. So all of these form IoT solutions that, pre-integrated IoT solutions that can be then deployed by our partners. Next slide. The other thing we have done with our partners, and we are doing, in fact, is promoting security, because as we have seen, security is a key issue for IoT, and it's critical to make IoT happen. And we have started an initiative to allow spreading the good practices in the industry and laying the foundations of secure devices that would well be a lot better than what we find right now in the IoT world. And this is taking into account all the life of the products, from the design to the manufacturing to the deployment and up to the end of life of the product. So all this life cycle needs to be analyzed, and we need to understand the threats that affect these IoT devices. We have done this analysis, and it's still ongoing, so it's not a finished initiative. It's something we have started with many other companies in the industry. We have started to architect solutions to counter these threats, and we also have started implementing some of these recommendations. So we have hardware that is able to support this platform security architecture, but we also release software, and we have launched a new open source initiative around that. So we try to bring with us the industry of around the silicon, but also a lot further, because we even work with operators and with the cloud providers to bring security everywhere in IoT. And that will be the end of my part. I will let others talk more about other things.
Okay, wonderful. Thanks, Mike. I definitely want to come back to some of those concepts that you talked about. So thank you very much.
Yep.
Great. And now we're heading over to Ken from Cradlepoint.
Hey, thanks. It's great to be here. Just to put it in context, I'll give a quick overview on Cradlepoint and then talk about some of the elements of IoT that we're really addressing. But Cradlepoint pioneered the use of 4G LTE as an enterprise WAN. We've deployed about 2 million units across 21,000 customers and are the worldwide leader in cellular routers. And we've had a lot of success in branch office and retail stores with multi-WAN, where 4G LTE is part of that multi-WAN strategy, and software-defined WAN as well. And we've been deployed in 75% of the top worldwide retailers, many Fortune 500, many Fortune 100 companies. We've also had good success in vehicle and kiosk deployments, including all the police cars in San Francisco, San Jose, and Chicago, public buses in New York City, Seattle, and San Antonio, and many smart city deployments involving everything from traffic intersections to environmental monitoring to recycling bins to video surveillance. And many of the deployments that we have are a blend of traditional devices and IoT devices. And it's this IoT element that we're addressing in our solutions, and it's really our focus is connecting, securing, and providing edge computing for IoT. So on the next slide, enterprise IoT is a fairly broad spectrum. Even, it's very, as Derek said, it's different than consumer IoT, but within enterprise IoT, there are three major, consumers of IoT, or people that are developing enterprise IoT solutions. One is you have IT departments, and they're not really developing IoT solutions, but they're deploying IoT solutions on behalf of other departments, whether it's the operations department or facilities department or marketing. The second group in enterprise IoT is really OT. And these are the people that are trying to improve their processes. And they're implementing IoT within their factories, within oil and gas, to improve yields, basically improve the process. And then the third group are product teams that are baking IoT into the products and services that they sell. And the reason I'm bringing this up is our focus is really on that first one. It's enterprise IoT, but it's the IT folks within those enterprises. And the three typical categories or applications that they have are mobile applications, such as vehicles or temporary locations. And then you have machines, so these could be kiosks, digital signage, etc. And then physical locations, such as branch office or retail stores. And what's interesting is that each of those locations, it is a blend of traditional devices as well as IoT devices. So in the police car of the future, you have ruggedized laptop, and you have the officer's tablet, but you also have body-worn cameras, fingerprint identification systems. If you pull the shotgun out of a rack, you have an IoT sensor that sends an alert up to the ops center. In a kiosk, there's typically an embedded computer in there with digital signage, but there's also front door switch, IoT, customer analytics sensors, could be Bluetooth or Wi-Fi beaconing, and temperature sensors. And then even a retail store, it's a blend of traditional devices such as the manager's laptop, but you also have digital signage and point of sale devices and surveillance cameras, etc. It's a rich environment for IoT. If you go to the next slide, we surveyed, and we used, if you're talking to IT, Spiceworks is famous for working with IT. So we worked with Spiceworks to develop a survey and surveyed 400 different IT professionals to find out what is their experience in deploying IoT and what are their top concerns. And it was interesting to see that 69% of them are either already have deployed IoT or are preparing to deploy within the year. And that tells you that they're not waiting around. I think most people's impression is that, most people would think that their IT department was in that 8% category, but they're really implementing IoT solutions. And when we talk to them, I'm sure about their concerns, I'm sure you'd all be shocked that security is one of the top concerns, but the cost is also a top concern. So, but let me jump into the security on the next slide. The internet was based on the notion of connect first and authenticate second. And hackers love that. Hackers look for devices on the internet, and then they use their hacker toolkits to defeat those devices. And many of these devices have known vulnerabilities, or people haven't changed the default password. If you think about the Mariah attack, it was mostly IP cameras that were compromised. And most of it was, they didn't change the default password, but it was a malicious malware that could spread contagiously from camera to camera. And if you're an IT department and that camera, one of those cameras was on your network, and it was launching an external DDoS attack, what they did is they brought down Brian Krebs' website. They also went after Dyn DNS, which brought down Netflix and Airbnb, other GitHub if you're a developer. But the problem is, if you're an IT department and your camera was used to launch an external attack, you'd be embarrassed. But if a hacker was able to somehow use that IP camera to further penetrate your enterprise network and be able to access information, private information that they shouldn't, you'd be fired as an IT department. And the IT guys are just under fire. They're at the neutral zone and they're under constant attack. The problem they have is they don't have the same tools that you have for PCs. So with PCs, there's a lot of standard malware, antivirus solutions you can buy, but IT devices have such a range of capabilities, processing power, memories, operating system, that there is no one-size-fits-all solution. And so if you go to the next slide, or excuse me, on this slide, the last thing I'll say is for IoT devices, if you look at the right side, there is a notion where it is called authenticate first, connect second, with the idea that if you can't see it, you can't hack it. And if you go on the last slide, I'll talk about what we mean for IoT security, and this will just tee up the further conversation. This is the last slide. And on this, it's a notion, it's using software-defined networking to improve the security of IoT deployments. And this specifically is something called software-defined perimeter. And I'll just hit the highlights of that. And there's additional information we can provide later. But the idea is using your existing network, whether it's a combination of broadband or LTE, the ability to use software-defined networking to create microsegments that enable you to put different IoT devices onto its own microsegment so that it's invisible to the outside world, it's invisible to hackers, but it's also, you're able to segregate it so that it is unable to communicate with other network segments or other devices in your network. And if you're an IT department and you're deploying these IoT devices and you don't have antivirus or clients that you can put on those IT devices, this gives you the ability to really provide security through separation and be able to comfortably do some of these deployments knowing that it can't be seen from the outside world. So with that, I'll turn it back over to Kelly.
Okay, great. Well, I'm glad that we're having such a robust discussion about security already, because honestly, that was one thing that I heard over and over from all the folks that I talked to about this is, you have to be thinking about this and it cannot be an afterthought. So, all right. For our audience, I would encourage you, please submit questions. We are in our Q&A section now. And so if you have questions for any of our panelists about the topic of enterprise IoT and devices or any of the things that they've addressed in their slides, we will get to as many of those as possible. I do want to address that question of IoT and security. So let's stay on that and I want to ask, do you guys see progress happening on IoT security? We had Mirai, that was a big watershed moment. I think that was 2016. And then we had, WannaCry, and that was ransomware. It was a little bit different. But I do feel like there's a lot more awareness now of, distributed denial of service attacks that are fueled by IoT devices. Ken, you mentioned folks just not changing the default password. And so there are a lot of things out there that are vulnerable that may or may not have any ability to be patched, to be, updated. And, so I don't know if there are some, I think, vulnerable devices out there that are just vulnerable. We just have to know that there's going to be. But hopefully, as we add more IoT devices, we can do better. Mike, I don't know if you want to start us off on this discussion with, your perspective from the embedded perspective, because over and over, I heard so many people, Cisco, Nokia, lots of folks saying, build it in from the beginning, because if you don't, if you try and go back later, you're adding expense and time that you might not. You might not do it.
Yeah, exactly, and that's why we have been involved very early in the security discussions. Unfortunately, when you start to build something at the chip level, it takes time to diffuse industry and get seen in the products that you can see on the market. Well, that's the life of the products. But clearly, we see that the first implementations of IoT have been just, take a normal product, just add connectivity, and that's it. And most companies just focus on the functionality and didn't really think about security. Some companies did, and more and more companies start to think about that, and that's why we also want to make sure that everyone understands what it takes to get to a secure device, and that's the fundamental behind our PSA, the platform security architecture that has been launched by ARM and its partners. The idea is that there are a lot of research results, good practices, and foundations that can be reused throughout the industry. The problem is that most of the companies who build my IoT devices do not have either the expertise or the time or the money to spend on security. So we need to kind of package that and make sure that it is easy to use. It is easy to use the best security features that you can get from the research in security, and to implement that in your products. If it's not easy and cost efficient, then it will not be used, and that will continue. We'll continue seeing these headlines where everything has been hacked, etc. So it's really important to spread this knowledge, spread the IP, the intellectual property that is behind security, making sure that we have software as open source that can be integrated in other software frameworks, that we have hardware that supports security, and then we can deploy easily secure devices.
Okay, great. Derek, I want to jump to you next to get your thoughts on on security.
Yeah, I started off in my initial slides talking about the castle analogy. So if you think of a medieval castle, if somebody builds a castle and then says, "Oh crap, we need to be secure," and they build a moat around it, they got a moat, and that's pretty good. But if your castle wasn't built from the first brick with security in mind, you're still going to be very vulnerable. So you need to have these layers of security, and it needs to be thought of from the first step. And still sticking with the castle analogy, like if you think, where's the king and queen's bedroom in their residence? Well, it's going to be up in a tower. Why? Because the tower has additional height. It's the last thing that get taken in a siege and such. So it's put up there. How do they lay the hallways? Well, do they lay them directly facing the outside so a cannonball could bust a wall and sail through a hallway? No, they're going to have angles in them. How do they lay the bricks in the outer wall? Well, they lay them with gaps in it called meurtrier. And the meurtrier are used to shoot arrows in multi directions and without exposing yourself. So it's a big hole on the inside and a small hole on the outside, so you can aim your bow and arrow. It's multiple levels of security, layers of security. And these are people, human beings, who have looked at, said, listen, we're going to be attacked from the outside. We're here. They have, for life and death choice for them, to think about the multiple layers, and so they have over the course of centuries and decades. And so when you think of a medieval castle, that is a great example of how we should be thinking of security in IT, and certainly IoT, is what's the multiple layers? And the idea of slapping a moat on after, like clap, clap, very good, the moat is helpful, but if it's all you got, it can be defeated. And security through obscurity is never a great thing, but it never hurts to have secret passages and other things like that, just make things obscure. And I think Ken talked about how it's better to have a dark planet, right? If people can't find you, you're much better, more likely to be secure. That doesn't mean that's your only layer of security, but when he shows that picture of a dark planet, well, that kind of makes it hard for the hackers to start. So that's an important thing. The other thing I'd say is more of a psychology, not an IT. I'm not an engineer. So this next security element is just psychology. If you do security as an afterthought or you do it poorly, you're going to be the first to get hacked. I liken it to the bicycles in the bike rack. So if I got an average bike, not a great one, not a horrible one, somebody might want to steal it, and I pull it up to the bike rack and I lock my bike. I think my likelihood of having my bike stolen is less related to the quality of my lock and more related to the quality of the other locks up and down the bike rack. If somebody didn't lock their bike, theirs is the first to go. If somebody's got a cheap lock, theirs is the second to go. So mine doesn't have to be impenetrable. It simply has to be somewhat better than the average lock. Once again, that's not the end-all be-all, but that gives you a psychological advantage. You're not the low-hanging fruit for the hackers. The last thing I'll say is in the automotive space, we saw Jeep get hacked by a couple of researcher hackers, and it was taken over remote controlled. Mm-hmm. And it was, and Jeep had some guilt in that, and Sprint was somewhat complicit too. Neither one of them had thought about security from the ground up. And so security was kind of an afterthought on that, and the two hackers simply had to breach one kind of wall to get into this Jeep and take full control. And so there's a couple of things to take away. One is that's the afterthought method. It doesn't work well. Second, it costs your brands a lot. It's expensive in terms of brand valuation and the black eye you're going to take. And third, I hope that Sprint, Jeep, and every other auto manufacturer and carrier out there took the lesson. And that's one of the good things is with properly functioning companies, we don't all need to make the mistake. We can at least learn from mistakes in a shared capacity. So I don't think other auto manufacturers are likely to do just like that with kind of afterthought security. And the last thing is, one thing that concerns me is that may be true for companies with large brand equity like Jeep or Sprint, but we have a lot of low-cost vendors, especially for IoT devices, coming out of, and I won't pick on China, but a lot of them do come out of China, but that's not the only place. But if we have these low-cost vendors who don't have a brand and don't care about brand value, they're not going to put the extra expense into investing in security. They're just going to try to get the product out the door as cheaply as possible and get those sales. So we have to be very concerned about these low-cost, not killing ourselves by sourcing it to the lowest cost vendor who's giving us maybe a product that's highly vulnerable, it might be worth investigating how many pennies more per unit will it cost for me to have security built in from the ground up, and that might be a worthwhile investment. So thanks.
Okay. All right, Ken. Give us some of your thoughts. You laid out some interesting concepts there in terms of SDN and how that can be applied to security.
Yeah, I think if you look at the life cycle of developing and deploying an IoT project, I mean, obviously you need some sort of device with sensors itself, but you also need that reliable connectivity. You need the security. And many times, and we have many customers, examples where they really focus on the device and the sensor itself without really thinking much about the connectivity or the security. That's where they started. And a lot of these started proof of concepts. And it turns out that the reliable connectivity and the security is actually very hard to do. And that's why many people don't start that. I think early on when Derek was talking about on consumer IT, the idea of using Amazon is kind of a common platform to get people started. It lets a lot of manufacturers focus on the device. And that's what we're seeing in the enterprise side as well, is we're focused on that connectivity, the security, and it lets people really innovate on the devices. But we have one customer that used a Raspberry Pi to develop a really good proof of concept, and it was going to be for a large 50,000 unit deployment. And it got shut down by their IT department. And the IT department looked at this and they said, look, there is no way that you can deploy this on our enterprise network. And they're the keepers of the enterprise network. They're the gatekeepers. And they list all these reasons. So I think one of the key recommendations I would have is, if you are an enterprise and you're planning to deploy IoT on your enterprise network, talk to the IT departments and use them as consultants so that you don't get blocked at the end of the project. And then second, just really understand that you can't save security for later. It's something that you have to address up front. And if you have the luxury of baking it into the design of your device early on, like what ARM has been talking about, that's great. But if you're procuring devices that already exist, just recognize that there are other layers of security that you can put around those devices as well.
Okay. We have a question from our audience about regulation in IoT security. Do you view the IoT industry as too young for regulation, or is it past due? Should the industry wait to regulate itself or wait for government to do it? And so I'm curious, Derek, since I think you have sort of a Silicon Valley view, I'm sort of curious if you have thoughts on that.
Yeah, it's funny. I was actually typing out a response to that question right now to answer it in the text format. Industry always prefers self-regulation over government regulation. And in general, I agree. If the industry does a decent job of if it's not just kind of a veneer effort, I would like to see self-regulation from the industry, because it can be more dynamic than government law, which kind of gets entrenched and never goes away. But if it's feckless, as sometimes industry does, then I'd rather see the government come in and actually do something. But I would say this is a case where I'd like to see industry do it. And the way I'd like to see it happen is, do you remember how hoverboards were the rage 3 years ago? They started popping up and they all started blowing up on people. And we said, what's the problem here? Well, the problem is, it's like I told you guys 5 minutes ago. The batteries are getting made in China by somebody who's looking for the lowest cost battery. And I actually bought one of those things for $1,200. And it's probably before anybody here ever saw one. I saw it at an early trade show and I scooped it up right off the show floor. And mine is still working 3 years later. Hasn't blown up, no problems. The prices started coming down, $1,200, and boy, 6 months after I bought mine, they're being sold for $300 at gas stations. And I'm thinking, wow, did I waste my money? I don't know. Well, those ones are the ones that started blowing up because Chinese manufacturers said, there's no patent on this thing. The patents are in the wild now. We're all knocking them off from those. There's DuckDuckGo, IO Gear. There's all kinds of different brands spitting these things out. IO Hawks, or not IO Gear. And all these different brands didn't care about their brand value. It was just a one day. They invented the brand on Tuesday. They had the product shipping on Wednesday. And so they went for the lowest cost battery, and those things were dangerous. So enter Underwriter Labs. Underwriter Labs says, these look like fun toys, but we can't have them blowing up. We're going to develop a certification process for these products. And if they have the UL stamp on them, that means they won't blow up under your feet. And now we have, it's not a rage anymore, but they're still for sale here in the US with the UL stamp, and they don't blow up on you because the batteries meet those safety standards. So what about IoT? What about we have an Underwriter Labs or somebody similar to them say, we have a logo. You can stick it on you can license our logo and stick it on your product if you meet the following standards. One, and this is just examples. One, you require the password to be reset. And I think Ken mentioned this. When you first get the device, you have to reset the password. Two, the data that comes back and forth is encrypted. Three, the manufacturer can demonstrate they have followed this security evaluation and they built it. And I don't know what program Underwriter Labs or their competitor creates, but regardless, it's something where at least the basics have been done so that the consumer can be protected, and not just the consumer, I mean whoever buys it. So it could be the enterprise who buys this device, can be protected from products that have been built as part of a race to the bottom. So I'd like to see an industry-based certification of this product has thought about security. And by the way, that doesn't mean it's great. We can still talk about which one's better and worse, but it means at least it wasn't like these IP cameras that were made part of the botnet last year. So where security wasn't even at all part of the design, or where users are using devices with the default password still in them 2 years after they were launched. So that's my hope, is that there's a certification process and that consumers get familiar with the brand, enterprises get familiar with that particular logo, and we can start using that for at least a minimum certification, because we don't know. We're not engineers, as I said. So give me that stamp so I can at least have some comfort, just like with my hoverboard.
And actually, I think it was last year, ICSA Labs, which is part of Verizon, did actually launch a certification program. And I know that folks like Wi-Fi Alliance, as part of Wi-Fi Certified, do make some attempts to to check to see is this particular device exhibiting a known vulnerability. I think Cracker was the big one that came up in the last 6 months or so. The problem, I think, is that not a lot of people know them. They don't have sort of the UL, they don't have the recognition of like UL yet across the ecosystem. And it's not necessarily the same. I think you run into some of the problems of fragmentation across protocols.
Absolutely, yeah.
So you run, what a certification would be for something like, Zigbee or Wi-Fi versus cellular, versus even satellite. There's, you run into, it's tricky. We did have a question about, you mentioned segmenting your network at the edge to isolate the IoT devices to heighten their security. Is this segmenting what telcos call network slicing? Ken, I wanted to jump back to you on that, because I thought, when you and I talked for the report, you had, I think, an interesting example of folks using LTE for their IoT devices specifically, and it was a way to keep them off of the enterprise network. But it wasn't necessarily what I don't know if I wouldn't necessarily consider that a network slice. I don't know. What do you think?
Yeah, I think there's two methods that our customers use to keep specific applications separate. One is where you use physical separation. And so, for example, we have a customer that's a bank that wanted to put digital signage in each of their branch locations, all 2,200 of them. And they decided to use a Cradlepoint router running on one of the carriers on LTE as a completely separate network. And they said, why would we put this application on our secure financial network? And for the digital signage, it freed up the users of the digital signage, the people producing the content, he or she, to be able to maintain that content. And the IT department at that bank didn't really have to worry about that as a risk. However, there are some applications where the risk maybe doesn't justify having a separate physical network. And that's where this notion of using software-defined networking to take advantage of your existing enterprise network and create an overlay solution on top of that is a effective way of addressing some of those other applications where, again, you may not want to create a separate separate network. So there's logical and physical. So, but I think the bottom line is there are different applications, different devices. They all have different risks, and you just need to understand what the risk is for that particular application before you make that decision.
Okay. Great. Mike, I want to jump back to you. We've talked a lot about security. I do want to touch on some of our other topics because although security was definitely one of the big topics that folks addressed, this report also touches on some aspects of considerations for IoT device design and testing. So, when devices are thinking about either developing an IoT device or buying one, what are some of the factors that they should be considering? I just heard, for example, battery life is a really important one. And I don't know, Mike, if there are other, sort of top considerations for thinking about how a device comes together.
Yeah, and that's exactly what we work on. In fact, at ARM, trying to build solutions and not just provide bits and pieces. And well, there are many things that are important for IoT devices, but the essential ones, apart from security, are obviously the battery life, because that's a direct impact on the cost of your device, cost of ownership. Because when you have to change batteries, well, not just the cost of the battery is to be taken into account, but also the access to the device, which can be really high if you think about agriculture or infrastructure monitoring, for example. So this is something to take into account. The other thing that is very important is the connectivity, because we talk a lot about different standards for connectivity, and in fact, each standard has its benefits and its drawbacks. We see a lot of IoT nodes in areas where you have short-range communications. In that case, it doesn't really make sense to use long-range standards like LoRa, NB-IoT, or Cat-M. It's probably much more energy efficient to use short-range communications like Wi-Fi, Bluetooth, 802.15.4. So this is also something to take into account in the design of your devices. And one other aspect is the price. We saw that in the slides at the beginning. The price of the solution is also something that is very key to the success of the deployment. And of course, in consumer devices, that's a key driver to the adoption of the product. But in enterprise as well, it has a direct impact on the ROI computation. So having devices that can be deployed at a reasonable price is important. And this price, in fact, is dependent on the cost of the elements that compose the solution. And on our side, of course, we work with silicon manufacturers, so we encourage silicon manufacturers to come up with optimized solutions. We try to help them to build these solutions, but you have many parameters to take into account. And for some applications, it might be better to choose off-the-shelf modules, etc. For some other applications, it's probably better to have your own chip, etc. So each application has different requirements that will lead to very different solutions there. But in general, what we see from our point of view is that we see a lot of new integration into the silicon. So less and less components necessary to build an IoT solutions, and these components being able to perform more and more complex tasks. So more complex processes, more processing at the edge. And this is an evolution that will allow better development, deployment of IoT, because the single solutions, single chip solutions will lead to much lower costs for the end devices.
Okay, great. All right, well, let's go ahead and jump onto a different aspect. Let's see. I'm sorry, I'm just going through questions here and trying to figure out which one we're going to jump to next. let's see. One thing I did want to talk a little bit about the edge versus the cloud, and I think this gets both to a point of what is the device's capabilities, and it also thinks about things such as cost. I had a lot of people say that businesses will often start with one sort of idea of what they want out of their IoT project, and then as they get further into it, they realize, we really want it to be able to do this, 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 and this as well. So flexibility, and that really isn't just about what the device itself is capable of in terms of sensors. It's also about what processing power does it have? Does it have the ability to add another application or two, or does it have the ability to communicate to a different system that the company may be bringing online? And so I'm wondering if maybe Ken, we can start with you in terms of thinking about what are the kinds of flexibility and and what you're seeing as folks evolve their IoT deployments. What are they sort of learning along the way?
Yeah, absolutely. I think first of all, some of the best products out there are a hybrid of kind of that on-premise or device functionality and the cloud functionality. And it's really, it helps on both the connectivity and the security and the bandwidth requirements. But the cost is one of the big ones. If you have an iPhone and you use Siri, the voice recognition, you're basically sending your voice print up to the cloud, and the supercomputers decipher what you're trying to say, and it sends the text down to your phone. If you tried to have that functionality on your phone, it'd probably be a $9,000 device to have that kind of compute functionality at the edge. And so you really want that blend. What we found in IoT is it really depends on how much data you're generating and how much you want to send up. So it becomes a bandwidth constraint as well, not just a cost thing. And for example, if you look at the amount of data that's being generated at the edge, it's growing exponentially faster than the ability of the network to process it. So you really want that edge computing to be able to reduce the load on your network, because it may get to the point where even if you wanted to transfer everything up to the cloud, you couldn't do it. A really interesting device I saw was a camera that was being deployed by one of the largest US cities. They were doing a proof of concept on one of their major thoroughfares. And they had, probably a dozen surveillance cameras. But rather than send all the video up the cloud to decipher, they used edge capabilities in the camera to be able to analyze, is this a bus, is this a car, is this a bike, and then provide parameters like speed, etc., and then send that metadata up to the cloud. And if you're able to use a combination of edge processing and cloud analytics, I think those are going to be the winners in IoT.
I'd like to jump in and agree emphatically with what Ken just said, and say that since I do a lot of work in the automotive space, just throw out that other example. And it's exactly what Ken said. Is like, if you have a simple IoT sensor that's sending off-on readings back to the cloud, or pressure readings, 80 psi, 70 psi, we're really not going to need to put any kind of edge processing on that processor. The amount of bits that it's sending up is trivial, so the cost of transmitting them is small. It doesn't make sense to spend more money on the devices. And of course, if you're having hundreds of thousands of devices in the field, the initial CapEx is what's really important. On the other hand, when you have a car, the amount of data that's captured by the car's variety of sensors and put in through to the this computer and central computer in a car is massive. And so if your car's not pre-processing that data before it sends it up to the cloud, you're going to have a huge, huge bandwidth bill. So if you look at the example of Tesla's, they do a couple of things pretty intelligent. First of all, they use their consumers' driving data to teach their fleet how to drive better. So my car, for example, will send data up to the Tesla cloud. It will do it at night over Wi-Fi if it can, but it's also going to pre-process it, so it's not sending every single bit of data that it read. So the pre-processing is extremely important when you're looking at high quantity of data. So I agree emphatically that it's kind of how many of these devices do we need? Is it a million of these end devices? Because then we want to make them cheap. And how much data is each one sending? And the more the data, the more you want to pre-process it.
Okay. All right, well, folks, we are going to end here with one last question, and that is each of your thoughts on trends in enterprise IoT for 2018. Derek, I'm actually going to start with you, and I'd ask you to each limit it to about a minute, but give us your thoughts.
Good. Maybe I'll try to do it in 30 seconds because I don't have too much here. I just think, as I said in my slides, that I believe that we're at an inflection point where the modules, the connectivity, the narrowband IoT, the opportunity to go with something like Sigfox, you can build a lot of interesting solutions out of the box today that even just 3 years ago would have been a very, very difficult thing for enterprise to build for themselves. So I think we're going to see an explosion of trials and actually larger deployments as well. Thanks.
Okay. Mike, your thoughts on trends for enterprise IoT this year?
Well, I would follow in the same direction. We see a lot of deployments going on. We try to help in that direction as well with the services and the elements that we bring to manufacturers. So a lot of new devices will come up, but now people start to think about security. So that's very good to see.
Okay, and Ken, let's end with you.
Yeah, I think what I'm seeing is that the rubber is starting to hit the road with a lot of enterprises who are choosing specific IoT projects to save money. I think I talked to a construction firm that had a construction site where they have this tens of thousands of dollars per day delay fee. But if it rained that day, they didn't have to actually pay that. It was a kind of a natural cause slippage, and they slipped 50 days. It was over $2 million of penalties. And they said, we can use IoT to address that and probably pay for it with the fines that we just paid. I've seen a dairy firm that is the leakage of milk crates. They want to use RFID tags to be able to solve a $30 million problem. So I think the trend I'm seeing is a lot of these enterprises are really buckling down and looking at what are the problems that they have in their enterprise and how can I use IoT to address that. So that's what I'm seeing.
Okay, great. Well, gentlemen, thank you all so much for your time today, and this concludes our webinar.